Hello, I'm Paul, a researcher at Camrys, and this is my Research Expo. I'm excited to share with you some of the work I have been doing in the area of graph data mining and network analysis. So here's the agenda for today. First, I will start with why map the FSL Twitter network at all. Next, I will briefly talk about the methodology and some of the associated research questions. We will briefly explore findings and some of the visualization tools that I developed for the analysis. And lastly, I will be holding a live Q&A session between 11 and 11:30, which you can join after this presentation. Okay, without further ado, let's begin with our motivation for mining and mapping the FSL network. In data mining, we study how to extract interesting and useful knowledge from large amounts of data. And this knowledge is usually hidden patterns behind the data and can often be very useful for informed decision making. With Camrys, the decision to conduct our research on Twitter was primarily motivated by the ability to collect and analyze non-mediated opinions and sentiments that would not be accessible in more traditional approaches otherwise. So we view this as a unique opportunity to truly understand the underlying characteristics of the FSL network online. The focus on mining Twitter for this research was mainly because of the fast information diffusion that exists on the platform, as well as the ease of connecting with Twitter to design novel applications that study its network. Here's an overview of our methodology and some of the research questions that we answered. As you can see, the questions are organized around the discovery of user nodes, analysis of influence, and data visualization. So let's jump right into it. A brief primer on the graph data model. The model for this application is rather simple. We can construct the network using nodes which represent a user profile, could be an individual or an institution, and we source this profile along with its attributes from Twitter. We then have edges that represent a follow relationship between nodes. Alright, so for this project, I analyzed a network of over 20,000 user nodes and over 335,000 edge connections, as you can see from the chart on the right. And the actual network is what you see on the left. The network was built from a community of 40 users, also known as seed users. The assumptions that led to identifying these 40 as key was a critical one, because the network analysis that follows depends on who the seed users are connected to. That is, who they are following and who is following them. For selecting seed users, I employed a hybrid approach of keyword search, where I used specific keywords and hashtags to identify which users are actively participating in the FSL conversation. Activity in this case was measured by the frequency of relevant keywords, phrases, or hashtags across all of a user's tweets. And secondly, manual research conducted by domain experts was also critical in identifying who to include in the initial set of seed users. Moving on to the second phase of our analysis, which focused on a very important question, perhaps one that was at the core of our analysis, and that is, who are the influencers on the FSL network? So the motivation behind this was to identify and present community leaders in the FSL network. The key benefits of this type of analysis is that it enables Camrys to take action in engaging influencers who can support our project, study their discourse on Twitter and gain insights on how they mobilize and what makes them attractive to other community members, identify the type of support we should offer, and lastly, gain insight on who is absent from the conversation so that the hub defines a strategy to reach out to the underrepresented on social media. So here's an overview of the solution architecture for the application I built to rank user influence on Twitter. More precisely, the research problem I was solving was related to how to discover top K influencers on Twitter using the set of seed profiles and their second degree connections as the input network. So in terms of the algorithm, I used the PageRank algorithm to approximate the influence of user profiles on Twitter. The reasoning behind the PageRank algorithm would tell you that it's actually not the number of followers that make a profile popular, but instead influence is measured by how important those followers are. It was also not entirely surprising, however, to discover that approximately 70% of the top 50 influential accounts are institutional, where only 30% are individual profiles. The image on the left represents influence rank of a user relative to other users. Essentially, the bigger the node size, the more influential this user is in the network. And the table is a compressed version of our findings, highlighting 10 notable accounts and their influence rank according to PageRank. Finally, using the Google Maps libraries, I was able to geolocate influential hubs. So the process was to extract geographical data for each profile and make its location searchable based on user-defined features or metadata. Overall, this improves the quality and clarity of our research findings. To protect the individual user's privacy, I replaced their personal identifying data with a cryptographic hash value, whereas such information associated with institutions or organizational accounts remains openly interpretable in the public demo. So that's it for today. I hope you found this talk helpful. To continue this discussion, I encourage you to join the workshop between 11 and 11:30, where you will have the opportunity to ask questions as well as sign up for the beta application. For further reading of the technical report or source code for the visualization tool, you can click on the tool links here. And with that, thanks for joining me today, and please don't forget to fill out the survey.